Okay, 5.5, just like 5.4, these formulas, things, you need to get them from the book. There's different ways to write these identities, or these double angle formulas, so make sure you have them written down. We are going to, I'll give you this handout for the rest of the formulas, power, half, product, sum to product, and that you're going to use them to find all solutions. All solutions means that you might have a list, or you might have some general 2 pi n or pi n or something like that. So you need to make sure that you have all solutions accounted for. Alright, so on this one, this is a double angle here, sine 2x, so that means I get to use my substitution from above. So 2 cosine plus 2 sine cosine. Now I can factor out the 2 cosine. And just like we've done before, we set each piece equal to 0. So cosine is 0 and sine is -1. Now, when I'm trying to find all of them, I have no restrictions. When is my x value 0? Well, it's at all 90 degrees. Oops, pi n, not 2 pi m. Because it's at 90 degrees, it's at 270 degrees, okay? When is sine -1? Well, it's at 3 pi over 2, but the only way I get to -1 again is if I add 2 pi n. So, I need to look at these overlap, and so this is included in this one. So I do not need to write both of them. That's the only solution that I need to worry about, because it's the only one. By the one will take care of it. Pi n will get me to 180, and then 3 pi will get me back, and it'll keep going back and around and around and around. So we're okay with that. Here I have sine, cosine, tangent, given this piece of information. When in doubt, make a triangle. We know that we're going to be in quadrant 4. Here's my angle. Because of the cosine, I know that this is 5, this is 13, therefore that's -12. So if I want sine of 2x, I'm just going to follow the formula, 2 sine cosine, which is 2 -12/13, 5/13, which is -120 over 169. Cosine of 2x is 2 cosine squared minus 1. So 2 5/13 squared minus 1. And the last one, double angle of tangent, is 2 tangent over 1 minus tangent squared. So 2 over -12/5 over 1 minus a -12/5 squared is 120 over 119. And check it. If you put sine over cosine, which is tangent, -120 over 169 times 169 over -119, hey, we get the same thing. You don't have to do that. You don't have to do the formula if you know sine and cosine. I'm just showing you another way. The double angles are not restricted to 2x and x, meaning we could have 4x, we could have 6x, we could have them in multiple angles on that. So what we have here, so let me just show you something here. If I have sine of 2x plus 2x, and that's what 4x is, I could do sine of 2x cosine x 2x plus sine 2x cosine 2x which is the same as 2 sine 2x cosine 2x. It's the same, but that's the proof for it. And if I have cosine 6x, that's the same as saying 2 times 3x, which is cosine squared x minus sine squared 3x. Alright, here I have expressed 3x in terms of x. So we want to first rewrite this. We're going to say sine of x plus 2x. We've got to break it down piece by piece here. Well, we can now separate that using our rules from before. Sine x cosine 2x. So it's using that pattern from the previous. Now I know cosine 2x, again, from previous, I get to substitute that. Sine 2x is 2 sine cosine. That's the double angle. And here's cosine. Distribute. So I get sine minus 2 sine squared. Oops. Cosine 2x is 1 minus 2 sine x squared, so that makes it cubed, sorry. Plus 2 sine cosine squared. Now we have sine minus 2 sine cubed plus 2 sine of 1 minus sine squared. Sine minus 2 sine cubed plus 2 sine, distributing here, 2 sine cubed. Combine like terms, we get 3 sine x minus 4 sine cubed of x. This is a multiply up here. That's why that became cosine squared. That's a multiply. So that's how we took a 3x and made them into single x's. Reducing a power. You could also look page 413 in the yellow box. So we're going to have sine to the 4th is really sine squared squared. Sine squared is 1 minus cosine 2x over 2 squared. And this one's actually really kind of long here. So let's hopefully go through here. So we get 1/2. I'm taking this 2 out here. And then I have the 1 minus cosine 2x squared. So all I did was I pulled the 1/2 out, so I had a linear term here. I'm going to square the 1/2, so it's 1/4. Now when I square this binomial, I get 1 minus 2 cosine 2x plus cosine squared 2x, because I have to do it twice, FOIL it out. So now I have 2 cosine 2x. This is going to come 1 cosine 4x over 2 because of this 2. So 1/4, 1 minus 2 cosine 2x. I now have, again, I'm splitting this half out, so 1/2 plus 1/2 cosine 4x. So I now have 1/4 minus 1/2 cosine 2x plus 1/8 plus 1/8 cosine 4x. I distributed the 1/4. Combine, we get 3/8 minus 4/8, common denominator, plus 1/8. And if I take the 1/8, I get 3 minus 4 cosine 2x plus cosine 4x. A lot of steps in there. This is one that's just kind of there for you. You're really not going to have anything this complicated, but it's just good to see how things translate through. Using a half angle, so that's page 414. Find the sine of 105. So note that 105 is half of 210. So I could say sine of u over 2, because that's the half formula I want to use. Alright, so if I want 105, that means I started with 210. So I get 1 minus cosine 210. So I have sine 105 plus minus. Now cosine 210 is quadrant 3, which means it's negative, and it references 30 degrees. So that's 1 minus root 3 over 2. At this point, it's a matter of simplifying that problem. So you should get plus minus root 2 plus root 3 all over 2. Put that into a common, get rid of the fraction. You can't have a radical in the denominator, multiply by it. Or I think it simplifies to a radical 4, so yours should be okay. Alright, so when we solve this, we're going to be on an interval, so we need to just make sure that all of our answers are in that interval. This is a half of cosine, so according to our half angle formula, we got plus minus 1 plus cosine over 2 squared, because of the square there. So now the 2 is going to cancel. So I have 2 minus sine squared equals 1 plus cosine. So move everything over. 2 minus sine squared minus 1 minus cosine. Change that to a cosine. And that's 1 minus cosine squared. So 2 minus 1 plus cosine squared. The numbers all cancel. Cosine squared minus cosine. We get to factor out of GCF. Set each piece equal to 0. So where is cosine 0 at? It's pi over 2, 3 pi over 2. And where's cosine 1 at? It's at 0. All of those are within my range, so that's where I'm going to be. Because I'm in a range, I'm not a 2 pi n or a pi n or anything else. Writing products as a sum, so this is page 415. Just following the formula, 1/2 sine 5x 4x. Again, it's just following the substituted product formula. So I get sine 9x minus sine x. And you don't have to go any farther than that. Last page, sum to product. This is on page 416. So we have 2 cosine 195 plus 105 over 2 cosine 195 minus 105 over 2. We're changing the sum to a product. So this is a summation. These are products. So we get 2 cosine of 150 cosine 45. Cosine of 150 is negative root 3 over 2 because it's in quadrant 2, it's negative, and it references 30 degrees. Cosine 45 is quadrant 1, cosine root 2 over 2. Do the combinations, we get negative root 6 over 2. Okay, find the solutions of sine 5x plus sine 3x. So we have 2 sine 5x plus 3x over 2. Cosine 5x minus 3x over 2. Again, just following the formula, it's in the book. So I get 2 sine 4x and cosine x. And because these are factors, I get to set each piece equal to 0. So sine 4x is 0. Well, sine is 0 at 0 and pi. So that means 4x is 0 and 4x plus 2 pi. And 4x is pi plus 2 pi n. Because we're counting, trying to get for all of them. So x is 0 plus pi over 2n, and x is pi over 4 plus pi over 2n. I need to come up with all of my solutions. So if n is 0, I get 0. If n is 0, I get pi over 4. If n is 1, I get pi over 2. If n is 1, I get 3 pi over 4. If it's 2, I get pi. When it's 2 over here, I get 5 pi over 4. If n is 3, I get 3 pi over 2. If n is 3, I get 7 pi over 4. And if I go to 4, I'm now at 2 pi, and that's out of my range. If I go to 4, I'm out of my range. So I stop, and that's a list of all of them that are in that interval. You will definitely see something like this again, in this concept where you have to list them all out, but not in, you got to know your product formula. Again, those are on the a worksheet that will be given to you. You won't be expected to memorize them. You just be able to expect to apply them.